Hello everyone, in this video we are going to discuss about conditions for the column splicing. Okay, so the next concept here is column splicing. So now we know that what is meant by column, but what is meant by splicing? Okay, what is meant by splicing? Any idea? So splicing is nothing but again making the connection. Okay, so far we have seen so many types of connections, but just in this column concept itself we have seen one type of connection. Which type of connection? Increase in the cross sectional area, that is built up column. So there we have made a connection or not to increase the area. Up to the example what we have seen is connecting the two channels. So in connecting those two channels we have used the connections or not. Of course that system of connection is known as either lacing or battening, or we have carried out that connection either by using lacing or battening. So that is also a connection. So what we have done in that case, or what happened in that case, whether in lacing system or batten system, what happened? Think what happened? So their cross-sectional area is increased. Agree or not? So initially individual channel will have one area, that is gross area, which is mentioned in the steel table. But after joining or after making the connection, that column is known as built up column, and the gross area becomes a twice in the example what you have discussed. Do you agree or not? So there what we have done, there we have increased the area. So whenever we are going to make a connection for increasing area, then such a connection is known as built up section. Okay, then that connection is known as built up section. But whenever we are going to make a connection for increasing the length, then that connection is known as splicing. Agree? Splicing is nothing but making a connection for increasing the length. For example, this is a column. Okay, so this is the structural steel member which is manufactured in the industry. Now assume that we are going to use this member as a column. So now, but we require a 10-meter column, but this is of 6 meter only. Then what to do? So again we take another 6 meter and we are going to make a connection. So now there is increase in length or not? Tell me, there is increase in height or no? So this is known as splicing. Okay, this is known as splicing. But this is one column and this is one column. I'm going to make connection by joining it. Now what happened here? Length is same. Here length is not increased, but cross-sectional area is increased. So if I made a connection like this is known as built-up section. If the connection is like this, then this is known as built-up section. Or else if the connection is like this, then this is known as slicing. Okay, splicing. Clear? Now coming to this column splicing, there exists only one small concept, that's it. Other than that, remaining concepts are not required from the exam point of view. So what is that concept? Let us see. So first, when column ends are machined, when column ends are machined, that is smoothened. So what is the meaning of it? Just in the diagram I will show. Okay, this is one column, maybe I section. Now we have to connect this I section to another I section, which is present here. Clear? So this is one I section, this is one I section. So now we have to connect it. So for connecting, we have to use cover plates and bolts. Agree or not? Either cover plate or weld, or cover plate or either for making a connection, either we may use cover plate and bolt or cover plate and weld. Agree? So now this is a cover plate. Okay, this is the cover plate, and we have to connect the cover plate to the flanges of this I section by using a bolt or weld. Okay, either we may use bolt or weld. In this diagram or in this example, I'm showing bolt. So like this column which is carrying a load is connected to the another column by using this. So this connection layer, this is known as column splicing. Now here we have mentioned ends are machined. It means if ends are smoothened, it means if ends are cut by a machine, so that if we take this marker an example, if you observe here, the ends are smooth or not. Agree? So now if we place this column, or the assume, of course it is a marker, but assume as a column. So if we place this marker on this marker, now there is a perfect bearing action or not. It means load from the top column will transfer to the bottom column just by the bearing action. Do you agree or not? Obviously. Okay, obviously. The reason the ends are machined, that is the meaning of it. So in this case, strictly speaking, the column splicing connections, that is cover plate and bolts, will not take any load. The reason the load from the top column is transferred to the bottom column just by the bearing action. So here the purpose of providing the connections for making the column splicing is to just to hold it. That's it. Just to hold these two members in a place. Agree or not, or in a position. But we have to design these connections or not. Agree or not? So for designing we require some force. Tell me. So for designing we require some force. So for that now we are going to make a assumption. What is that assumption? We are going to assume that this load P. So strictly speaking, in a column when they are completely machined or the ends are smooth, so then total load from upper column is transferred to the bottom column just by bearing action. But for the purpose of designing the connections, that is cover plate, designing the dimensions of cover plate and number of bolts, what we are going to assume here, the load, it means the total load P. So in the total load P, 50%, that means P by 2 load is transferred from the bearing action and remaining P by 2 is transferred from the connections. So here we have provided connections on both sides. So now total P by 2. So the force on each is P by 4. So now we are going to design or decide the dimensions of this cover plate and number of bolts for this force in this case. Now here you should observe that in case of column ends are machined, then we are going to assume that 50% of load is transferred by the bearing action and remaining 50% is transferred by the connections. But strictly speaking, total 100% of load is transferred by the bearing action itself. But for the purpose of deciding the dimensions or the design of the connection, this assumption we are going to take. So take it down. Show it in the diagram. Okay. So now next case 2. So when column ends are not machined. So case 2 is when column ends are not machined. It means they are not smooth. So if I want to show here, so they are like this at this junction. So they are rough, somewhat rough. Okay, they are rough. So in this case, column load is not transferred just by bearing action. So because of bearing action, the column load will not transfer. So from the load from the top column P will not transfer by the bearing action. Now in this case, the total load has to be transferred by the connections itself. Now obviously here we have provided connections on both sides. So now each connection has to transfer half of the total load, that is P by 2 and P by 2. That's it. Simple thing. This is only the provision given in the code book. Okay, take it down. So when column ends are not machined, then we have to assume that the load is not transferred by the bearing action. The total load is transferred by the connections itself. So connections has to transfer 50% of the total load. Each connection has to transfer 50% of the total load. Clear? So take the diagram.